Okay, guys, this is some help on the worksheet from May 11th, and I'm also going to tie in the assignment for May 18th. So these problems on this worksheet come from the previous week's long assignment. Number 1 on the worksheet, I'm going to work 4 of them. Number 1, 1, 3, 5, and 7. Number 1, if you did the previous worksheet, page 5, this is one of the problems on there. So it's just adding one more thing. So here's how you solve. When you have a quadratic like this, it's equal to 0. First step is factoring. And the reason I have the 2 and 1 there is because these are the two numbers that multiply to 2 and add to 3. 2 times 1 equals 2, and 2 plus 1 equals 3. There it is factored. Now, because it's equal to 0, either this factor has to equal to 0, which happens when x equals negative 2. Negative 2 plus 2 is 0, and 0 times anything is 0. Or when x plus 1 is equal to 0, or x is equal to negative 1. There's my solution, and I'm done. Okay. Number 3 on the worksheet is very similarly done. It's going to be x plus something times x plus something else. Now, because they multiply to a positive number but add to a negative, they're both going to be negatives. And what they're going to be is negative 4 and negative 1, because those two multiplied give me 4, and negative 4 plus negative 1 gives me the negative 5. Now, for those two, either one of those factors to be equal to 0, x has to be equal to 4 for that to be 0, or 1 makes this factor equal to 0. And that's my answer. Okay. Number 5. Now, if you don't get why I did what I'm about to do, look up on the internet difference of squares. Difference of squares. I have a squared minus 49 is 7 squared. So that factors to a plus 7 times a minus 7. Again, difference of squares. And you can confirm that they're the same thing by multiplying a plus 7 times a minus 7. The middle would add to 0, leaving you with that. So the values of a that make each factor equal to 0, negative 7 for this, positive 7 for that, and there's my answer. Now, number 7 is the first one on this worksheet where you have a value of a. Now, when I say a, quadratics can look like this. Ax squared plus bx plus c. A is the value with the x squared, b is the value, so it's the x, and c is just the number, the constant number without an x with it. So a is 7. Let me just show you this right here. I could think of a as being 7, b is 6, and c is negative 1. So the first step in solving where a is greater than 1 is I'm going to multiply my a times my c. Okay, that's negative 7. Now I'm going to look for two numbers that multiply to this AC and add to my B. And see, it's positive 7 and negative 1, because these two multiplied give me negative 7, and these two added give me positive 6. So I replace my 6x with 7x minus 1x. And that right there, that's the same as 6x, but it allows me now to factor out a greatest common factor from these two. 7x goes into both of these, so I pull out the 7x, and that leaves me with x plus 1. And then for these two, there's really nothing common, but but 1. So I'm pulling out a 1, and because they're both negative, making it negative 1, leaving this. Now, because x plus 1 in parentheses is in both of these parts, I'm going to pull it out like a common factor. Okay? And what does that leave in the other one? It's the two things that were not in parentheses. 7x minus 1. Okay? So, now for the solution. What does x have to be equal to? Well, if this is negative 1, it'll make this 0. And if x is, I'm a little bit uncertain about that. I'm not, but it's more difficult. I want that 7x minus 1 to be 0. So what I'll do is I'll solve this like an easy algebra problem. Add 1 to both sides, and then I'm going to divide 7 from both sides. And that gives me x equals 1/7. There's my solution for number 7. Okay? There it is.